Picture this. You're sitting in your IGCSE Computer Science 0478 exam. You flip over to Paper 2, Algorithms, Programming and Logic, and boom, there it is. A massive flowchart question worth a huge chunk of your final grade. You sketch it out quickly, you're feeling pretty confident. But what if I told you that a single, tiny, misplaced line or an off-by-one loop could literally cost you all those easy marks? Well, welcome to this explainer. Today, we're diving into the exact step-by-step strategy you need to absolutely secure top marks on your flowchart and algorithm questions. We're going to completely eliminate those tiny, invisible errors that examiners are actively hunting for.
Okay, let's dive into this. Take a look at this setup. We've got a simple array named student mapped from index 0 all the way to 19, which holds the names of 20 students. The flowchart here is trying to output all 20 names. But there is a fatal flaw in how the loop counter is actually being tested. Can you spot it? Seriously, if you run this logic right now, you're either going to crash the program completely or you're going to leave a student out entirely. In just a moment, I'm going to show you the exact examiner clue that changes this answer completely and exactly how to fix it. But first, we need to build the underlying framework that makes that clue super obvious. So stick with me here.
So here's our roadmap for today. First, core flowchart logic. Second, the full mark answer framework. Third, correcting the exam answer. Fourth, IGCSE exam strategy secrets. And finally, the final step.
All right, Section 1. Core flowchart logic. Mastering the basics.
Now, you gotta remember, the Cambridge mark scheme is incredibly strict about geometry. You've got 4 essential symbols to work with: the oval for start or stop, the parallelogram for input or output, the rectangle for a process or calculation, and that diamond for a decision. Listen, if you try to use a rectangle to ask a user for their name or a parallelogram to add 2 numbers together, the examiner is going to penalize you, period. Even if your code logic is otherwise flawless, you have to respect the shapes. Each one gives a very specific, detailed description of what the algorithm is doing at that exact microsecond.
Now, what's really interesting here is the exact logical difference that causes most students to drop marks on loop questions. The syllabus literally asks us to understand the different ways of writing a flowchart to output those 20 students stored in our student 0 array. So, you've got 2 main choices. First, a precondition loop, where the loop counter is tested at the very start, before any actual processing happens. And second, a postcondition loop, where it's tested at the very end, after the code is run at least one time. If you mix these 2 up, your loop might run 21 times instead of 20, looking for an index of 20 that simply does not exist. And what happens? The whole thing crashes.
Moving on to Section 2, the full mark answer framework. Secure every mark. Look, understanding the logic, that's really only half the battle here. This 4-step framework I'm about to show you is your ultimate defense against dropping marks on written explanations. When you're answering a long-form question, please don't just dump information onto the page. Follow this exact path. First, state the concept, like saying precondition loop. Second, explain the mechanism. It tests the counter before the code executes. Third, provide the scenario application. It ensures we only output names from index 0 to 19. And fourth, the consequence or examiner wording, preventing an out-of-bounds error. By stepping through this exact logical sequence, you are handing the examiner exactly what they want, tied up with a bow in a highly structured way.
And that actually brings us to a golden rule, straight directly from the syllabus guidelines. Quote, 1 mark usually needs 1 distinct technical point. Avoid repeating 1 point in different wording. End quote. I see so many focused learners writing these massive, sprawling paragraphs that just say the exact same thing 3 different ways, hoping one of them magically sticks. Guys, it wastes your precious time and it earns you absolutely 0 extra marks. 1 distinct technical point equals 1 mark. That's it. Use the framework, make your point, and then just move on.
All right, Section 3. Correcting the exam answer. Fixing the fatal flaw.
Okay, here is the resolution to that cliffhanger from earlier. To safely output exactly 20 names from the array student 0 to 19, our corrected logic uses a precondition loop. Why? Well, because we initialize our counter at 0. Before we output a single thing, the diamond symbol, remember, our decision shape asks, is counter less than 20? If yes, we use our parallelogram to output student counter. Then we use our rectangle to process counter equals counter plus 1, and we loop right back around. The very moment that counter hits 20, the condition becomes false right at the start, and the loop stops immediately. No crashing, no missing students. The real examiner clue here is identifying those array bounds, 0 to 19, and making absolutely sure your decision shape tests that exact boundary before execution.
Let's hit Section 4, IGCSE Exam Strategy Secrets, Quick Wins for Paper 2.
Examiners absolutely love to set a trap with these two terms, so do not confuse validation with verification. Validation is an automated check by the computer to ensure data is sensible and reasonable, like, say, checking if an age entered is between 0 and 120. Verification, on the other hand, is checking that data has been accurately entered or transferred. Think double entry, like having to type your new password in twice, because, let's face it, we all make typos on our phones. You need to draw a hard line between these two concepts in your mind, for sure.
Now, when you're asked to evaluate or test an algorithm, you absolutely must know these 4 distinct types of testing data. Normal data is data that should be accepted without issue. Abnormal data is data that should definitely be rejected, like, entering letters instead of numbers. Boundary data tests the exact edges of acceptable conditions, like 0 and 19 for our array earlier. And extreme data, that is data that is valid, but it's sitting at the absolute upper or lower limits. Memorize these 4. They are guaranteed easy marks if you just apply them correctly to whatever scenario they throw at you.
And this brilliantly illustrates how matching the exact command word completely dictates the required shape of your written answer. If they ask you to state or define, be incredibly concise. Seriously, don't write a novel. If they ask you to describe, you just list the characteristics. Explain means you must provide the why or the how. And hey, this is exactly where you pull out our 4-step framework. Calculate or show means your working out is literally just as important as the final number. And suggest or evaluate means you absolutely must take your knowledge and apply it directly to the specific scenario they gave you.
Finally, Section 5, the final step, your revision plan.
So, what does this all mean? The crucial point is that you now have the tools to operate on pretty much any broken algorithm question like a total surgeon. You know the exact terminology. You have the frameworks. But knowing what to study and when to study it is honestly just as important as knowing the material itself. Time management is the ultimate unresolved problem here. To truly conquer Paper 2, you need a precise, actionable strategy to bridge the gap between just understanding these concepts today and mastering them under the intense pressure of your final 7 days of revision.
To get that exact 7-day revision map, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Make that your next obvious step. But until then, I want to leave you with this. If you sat for Paper 2 tomorrow morning, are you absolutely confident your loops wouldn't crash? Keep focused and keep learning.